want to mention that immediately I thought it was e to the x plus 1 on top, but I realized that was a mistake, and that means that this is going to take a lot longer than I expected. This looks very similar to a problem I did recently, so we're going to make u equal to root e to the x minus 1, and then we're going to square both sides. U squared is equal to e to the x minus 1, and let's go ahead and find du, or 2u du, is equal to the e to the x dx. And there's our dx value. So let's go ahead and plug that back into our integral. Let's simplify this. I realize that should have been a du. Let me erase that now. Before I even try to multiply the e to the x into that parentheses, let's go ahead and utilize what we found for u squared and add the 1 to the other side. And that means that we can use that u squared plus 1 for the e to the x in our integral. And now let's simplify this. Looks like things got a little more complicated. And the way we're going to solve this is using partial fraction decomposition. Okay, let me go ahead and make some space on the blackboard. All right, so that's going to give us that 2u squared is equal to the value on the bottom of cu plus d should have been a u squared plus 2. So let me just change that real quick. I had to move it so my face doesn't block the work there. All right, so let's go ahead and distribute. That's that first part. And let's go ahead and combine some like terms. If we're going to match this to the expression on the left side, we have to set a plus c equal to 0 because there are no u cubes on the left side. But b plus d is equal to 2. 2a plus c is equal to 0. And 2b plus d is also equal to 0. Let's play around with this. So that means that c is equal to negative a. We can utilize this for the third equation. So we have 2a minus a is equal to 0. And so that tells us that a is equal to 0. And if that's the case, then c is equal to 0. And now we'll use that second equation and say that d is equal to 2 minus b. And we can use that for the last equation. 2b plus 2 minus b is equal to 0. And we get that b plus 2 is equal to 0. So b is equal to negative 2. And that means that d is equal to 4. So this is going to be the integral that we have now. Negative 2 over squared plus 1 du. I'm going to split this up. Let's go ahead and create some more space because this is going to be our grand finale. So we have the integral negative 2 over u squared plus 1. Hopefully you can kind of already tell what these are going to equal to. That first one's going to be pretty simple. Just going to be negative 2 arctan of u plus 4. And now we have to be very careful here. This is still an arctangent, but we just need to make sure to rewrite the bottom as u squared plus root 2 squared. That way we can visualize and see that arctan. So that means that our a value in the standard form for the inverse trig integral is going to be 1 over root 2 arctan of u over root 2, and then we have our plus c. Now I'm going to go ahead and plug in our u, which was that root value, and then we have our final answer as negative 2 arctan of root e to the x minus 1 plus 4 over root 2 arctan of root e to the x minus 1 over root 2 plus